Thanks, Brinda ma'am, for inviting me to share my thoughts on this, IoT applications. And this topic is like, so now, as you all know, the buzzword is 4G, 5G, 6G, right? So now the trend is changing, and the way the network was implemented in the 2G or 3G era, and now it is totally different. The way they're progressing. So just and also so many applications are coming up, and so many um, uh, so many applications are coming up, and so many technologies are together, and then it is sort of it's no more traditional networks. It will be a kind of hybrid networks, I would say. So with this premise, so I will start with my talk on the IoT applications. And just, madam, can you see my screen? Madam, can confirm if you can see my screen?
Yes.
Okay, thank you. So these are all my agenda of the for the today. And one is we'll start with the preliminaries on the slight touch upon on the 5G, how what are all key enablers in 5G, and then a little bit about the frequency spectrum. And we'll start about the we'll talk about the some of the functional splits. You might have studied OSI layers in your class subjects. So how they it is really implemented in the network. Then we'll start with the use case applications, and followed by, if time permits, we'll talk about some of the challenges and opportunities for as an EC engineer, and there's some simulation testing and tools and so on. Okay, so I think I have 1 hour for today, and then I will try to cover as much as possible. Okay. Now, the preliminary is like, we'll start with the introduction to 5G. Okay. So the 5G is nothing but, you can see that, we started with our, era of, for example, analog phones, where you will have a big antenna like this. Even now, you can see that, satellite phones are, are of sort of that nature. And then, they were thought of introducing doing, they wanted to ensure the mobility while they're talking. So that's why 2G came into picture. 2G came into picture. Okay. Um, just give me a moment, please. So I'm sorry. Can you hear me now? Can anyone confirm? Hello? Okay, okay, madam. Okay, madam. Okay, so okay, we started with the analog voice phone, where you cannot move much, and then we started with the digital, like some kind of a digital voice, as well as the some kind of later in 2G they introduced SMS. See, somebody is not available when you are calling, so you can just text it that you can inform anything in well in advance, so that whenever they are available, they can they are free to see that SMS. So that's why SMS feature came in. And a small a kind of internet surfing also they introduced as in the technology called GPRS or Edge. Okay. Then in 3G, they started focusing on the voice as well as the data. So in a different way, because in 3G, we had two technologies together. For example, in the air between the base station to the user equipment, or we can say mobile, it was a CDMA technology, and from the base station to the core network, it was a GSM technology. So it was the kind of disaggregated network. First disaggregated network where you are using two different technology in the same platform. Okay, same network. And in 3G, the advancement, like for example, though they got some kind of speed in the internet, and also you could make a video call and like on a kind of live streaming and voice calls also somewhat better than 2G. Okay, because then some IP based network came into picture in the during the 3G era basically, because so much of optical fiber deployment and IP switching based technology came in the place of 3G. Okay, then in 4G, the main motive was like, to enhance the data throughput and also to support, to integrate the some of the networks. For example, your Wi-Fi networks. You might have witnessed that your Wi-Fi networks, right? For example, whenever you are connected to Wi-Fi, when you make a call, okay, if that network supports Wi-Fi call, it will automatically routed through the Wi-Fi call. Okay, so that way, they are offloading the some of the your networks to the with the help of other technology like that. And in 4G,
You.
hello, yes, please. Can you hear me? Can anyone confirm? Hello, hello.
Sir, you are audible, sir.
Okay, okay, okay. Somebody was talking. Okay, no problem. So then in 4G, what they did is, in 4G, in especially the IP-based calls, you might have heard of, VoLT, right? That came into picture. Then in 5G, a paradigm shift has happened, for example, under three umbrella term like EMBB, enhanced mobile broadband, which is for the mainly for the high throughput, very high throughput, I would say. And in the second application was machine type communication, integrating machine type communication with the networks. The third one was to cater for the, for example, URLLC, ultra reliable, low latency communication based, ultra reliable, low latency communication based network. For example, healthcare, medicine, or autonomous cars and so on. Okay, that's about the 5G. And in 5G, the advantage is that in 5G they leveraged some of the frequency band as well. For example, both in the LT, both in the sub-6 as well as the millimeter wave, they got a huge amount of spectrum, I would say. In the sub-6, approximately 200 megahertz are leveraged, but each operator may get up to 500 megahertz, especially in India. And in millimeter waves, you have plenty of spectrums. So some are licensed, some are non-licensed. So you have good flexibility to cater for the first one item in the 5G, like enhanced throughput. Okay, and the second aspect of 5G is like one is so far we have been seeing these kind of coverage, like in your tower you might have seen three antennas will be there, three antennas like this to cover 360 degree basically. So each antenna was intended to cover approximately 120 degree each. So total you can cover the 360 degree. So but the disadvantage here is that you can see here that whether user is there or not, still the coverage is there. Okay, so you keep on pumping the power. So therefore, if one user is there, still your network has to be active, and so many power is being dissipated there. Okay, so but the coverage ranges reduces. Okay, I would always say the analogy like for this is, for example, you have a torch light. Okay, you just remove the glass reflector, and then if you just switch on the torch light, you will not be able to the light will not be visible beyond 5 meter or 7 meter. Okay, but the moment you connect that that glass reflector, then your vicinity will go beyond I think approximately 50 meter or 100 meter. Okay, so that's the concept they introduced here. So when you have broad coverage, then your coverage broad beam, then your coverage range is going to affect. So therefore they introduced the beam forming technique, where you can just focus your energy to the particular towards the user. Okay, so the technology is there, and that is introduced by with the help of massive MIMO and also the traditional MIMO radios as well. So in traditional radio MIMO, for example, 88R or and a 16, you will have fixed beams. Will be, for example, 4 or 5 8 beams will be, sorry, 4 beams are maximum. 4 beams will be there in the fixed direction. But in massive MIMO, you can have a flexibility of you can sweep, or you can refine wherever the user is following. You can just trigger the beams towards you wherever user is on. Okay. Next, about the antenna technology, like, in 2G we had only single input, single output, one to one communication. And in 5G, 3G, then they introduced, for example, in base station side, there's some advancement was there. For example, RET, RRH, the concept came into picture. RET means just tilt the coverage range towards wherever you want. Okay, then we had 4G. In 4G we had we got some MIMO technology introduced in both in UE as well as the base station side. Okay, and in 5G it was further enhanced to have for example massive MIMO, beam forming, and number of carriers also increased. So many mm, things were increased. Okay, but at the cost of complexity. But we are getting benefit of, for example, energy savings, and total cost of ownership is being reduced, and many more applications. Okay, so everybody talks about the 5G, right? So what are all key enablers? According to I just brief about it. There are many key enablers are there, out of which I just shortlisted few of them, highlighted here. Like, one is for very high speed data rates. We are having huge amount of spectrum, so it is obviously the first one checkbox is done. Next is the ultra densification, which means you will have a huge amount of small cells, because in the reason behind this is, when you have a bandwidth, for example, when you are going for higher frequency spectrum, for example 3.5 gigahertz. Okay, you have a huge spectrum available, but the problem is you need to have multiple towers, multiple cell sites, because you cannot cover beyond certain range. For example, as like you are doing for the 2G, for 900 megahertz you can put tower up to, for example, in highways you can put for I think 15 kilometer, 15 to sometimes 20 kilometer also. Okay, even beyond that also. Okay, but in city you can have a tower every, for example, 1 kilometer or so, and so on. But in 5G you cannot do that, because 3.5 gigahertz is almost 3 times, 4 times that of the 900 megahertz, right? So the wavelength reduces, path loss increases, and there will be a, I will shortly touch upon that, why frequency is important. Okay, so you need to have multiple, say within 20 kilometer, you need to have at least 5 sites or 6 sites, why even for the highways. Okay, so that's the scenario now. Okay, next is MIMO introduced, okay, along with the beamforming, and then advanced modulation techniques. Okay, so that's why whenever we study, even when I was studying, okay, what is this modulation technique? How come it is helping any technology that grows? But it is the reality now. Okay, so here is that you are using the same spectrum. Okay, same spectrum, same configuration, everything. When you start increasing the modulation order, okay, you see that capacity is being increasing, okay, for the same conditions. Okay, so therefore the modulation, which means, so what is obvious thing is here, for QPSK it's a 2 bits that will give you, for example, 4 constellation points. So 2 bits means, which means in every symbol, we used to call it as, in 5G we call it as symbol by symbol, PRB, like that. There is several nuances are there. So what we'll do, in a symbol, we'll encode the 2 bits in it. Okay, if you are increasing the order of the modulation, for example 16 QAM, I will embed 4 bits at a time. If I am using 32 QAM, then I 5 bits at a time, which means you are doubling, or X times you are increasing your capacity without, having much disturbance in the much, which means, you are increasing the spectral efficiency. You are using the same spectrum, same carrier, but the throughput is becoming very high. Okay. Next is heterogeneous devices and applications. For example, mobile broadband, then massive, type communication like IoT, device to device, and so on. Okay. So various networks are coming together, and then you will see coming together, and vehicular networks. So many things are coming up, together with the 5G. Okay, because the thing is, see, it's a fact that in 4G itself, you are happy. We are all happy, right? So we can surf, you can watch videos, you can make a calls, you can just work from home, take your phone. But in 5G, even more data capacity. For example, they are promising around 1 Gbps downlink, uplink will be around 380, 280 Mbps. Okay, so where you will use that? Okay, even normal user we cannot use that all the time, right? Okay, so even work from home, it's fine. Work from home, or during Corona time, it's fine. But when you start moving here and there, then you will not surf that much, right? We have to. It's like the operator, those who implemented, those who spent a lot of money on this network, they will ensure that a capacity network capacity is fully utilized, right? That's why they are bringing in various application into your things. For example, in your mobile also, you will see a lot of upgrades are happening. Each requires, earlier we used to browse with the 64 kbps, but now even 1 mbps is also not enough to run some applications. For example, games. Okay, augmented reality, virtual reality, and all. So that's why they are bringing in so many applications to cater, for example, to make sure that 5G is engaged, 5G capacity is fully utilized. Okay, now that's what heterogeneous devices and applications. Next is low latency, where how it is ensured is that one is integrated design protocol as well as the core network. Now they are going for integral form of network basically. So you can see that sometime you can see that physics, you might have studied OSI layer, right? Layer 1, layer 2, layer 3, physical layer, data link layer, and network layer, transport layer, like that, right? So sometimes one box will do all the layers, will run for all the, at least three layers, layer 1, 2, 3. These are all three layers are very important for the network. So they are integrating all in one box. They are running. Okay, you can just plug and play type of things are coming up. So when you start integrating the modules, so what is happening is you are reducing the latency, which means latency means when you, for example, in your mobile, simple example is in your mobile, you are dialing, okay, now some number, right? So you just take 2G phone, just normal keypad phone, and 4G phone, okay? When you start dialing, just, at a time you start dialing, you will see that in 2G network, now it's fine, but in earlier, no, when you dial, you will wait for at least for a second, okay? A few milliseconds to seconds, or, some seconds also. But in 4G, if it is Vivo LTE, it will be in milliseconds time, or microseconds time. It just numbers get dialed. Okay, so that's the speed. That is what is the latency we used to call it as. Latency means, so you are dialing, your number is verified in the core network. So end to end, the other person is connected. So till then, how much time it takes to establish the connection? So that we call it as latency. Okay, so how much latency it took? Okay, so now they are reducing the latency because of various things. For example, moving intelligence to the edge of the network. So much intelligence are moved to the edge of the network, which means you are near to the your mobile. Okay. Now the next is concept is important concept is called network slicing. So network slicing, what it does is, see, some network, some applications need more speed, but does not require any latency. Okay, for that you will have certain kind of architecture running. So all this network slicing, you can see here, for each application you will see different slice. We can say that different architecture. Okay, so this will only happen if many things are cloud based. Okay, cloud based, microservices based. If it is a hardware based, you cannot just somebody cannot go and connect it, right? So that's why now many networks are going into the cloud basically. Okay, So that's just okay. Coming back to this frequency spectrum, so we have plenty of frequency spectrum, frequency bands basically. So how they decide the bands? Somebody maybe thinking that okay, just you just write some frequency names and then you just put it in the box. Somebody will pick it. No, not like that. Okay, so it is the each frequency what they define. Each frequency. Hello, hello, Mr. Muti. Can you please mute yourself? Okay. So hello, Murthy. Can you please mute yourself?
Sir, now unmute yourself, sir. Sir?
Can you hear me, madam?
Yeah. Yes, sir.
Okay. So the frequencies are decided based on the huge measurements. It's not like randomly picked. Okay, for example, 900 megahertz or 800 megahertz. There will be huge measurement efforts are behind the each frequency band selection basically. So for example, they take a concrete wall and glass, and you can see here, see the concrete wall, glass, and you can see here the various scenario. For example, buildings, urban, semi-urban, rural, and and also with the forest area and many things they will consider doing the measurement. So he is the one, Theodore Rappaport, who used to do this measurement kind of measurements. So ultimately, what they are doing. So the thing is that you will have a TX antenna, the RX antenna. You will send, generate some frequency here and then transmit it. And, initially you will calibrate the system, for example, TX to RX, okay. Calibration means you will ensure that all zero, you make it as zero. Then you place your test material, for example, concrete wall, glass or something and so on, okay. Then you measure the received power level. So this will be always lesser than what you received in this scenario, basically, when there is no material, okay. So that net difference is becomes attenuation, basically, okay. Then based on that only they will decide that okay, the frequency versus the absorption or attenuation, or so they will we have plotted the graph where you will find that whichever is giving lower attenuation, then we will choose those frequency bands. That's it, okay. So that's why frequency band is very important, because now you might have seen, I think you will be hearing very soon, like in 5G also they are struggling with the 3.5 gigahertz, because a lot of interference is used, and also not it's getting attenuated, and it will be optimized very soon, okay. Next is, yeah, so many people we used to think that okay, capacity just comes whenever you have bandwidth, right? I think I highlighted a few points, like for example, uh, you know, few points, like for example, a frequency spectrum, modulation schemes, various other scenarios, right? So that's why this comes from fundamental theorem, like Shannon's capacity theorem. So the capacity is directly proportional to the bandwidth. Okay, bandwidth, when you increase the bandwidth, you obviously get the throughput higher. Okay, and you have a number of RX antennas you are increasing, which means your user in your mobile, whenever you start increasing the number of RX antennas, you can just capture multipath antenna, multipath signals, and then do rake receiver, or for example relay fading, or whatever it may be methods you can apply, and then you can fetch the data correctly. Okay, next is SNR is very very important. Okay, next SNR means signal to noise ratio, increasing the number of TX antennas. And we have a channel matrix. So channel matrix means, see, you have a complex signal, mechanism, right? So signal will come from this side, this side. You have to process that signal and then fetch out the actual data out of it. Okay. Next, we move on to functional splits. Okay. So as I mentioned some time back, you can see that till layer 3. Okay, layer 3. So layer 3 means network layer, like layer 1 is physical layer, tetherlink layer, then network layer. Okay. So the layer 3 you have you in network we call it as CU, DU, RU. In 3GPP side we call it as E node B. Okay, or G node B. Okay. So the OS three layers will be running in that. Okay. Here you can see here the radio unit will be on the tower. Okay, and the DU will be on the shelter, and the CU will be somewhere else. Okay. So each DU will cater for some of the many RUs, basically radio unit, and each RCU central unit will be catering for many DUs basically. So what it ultimately does is, see, here in most of them will be hardware based, here and here it will be a software based. Okay, these protocols are running in as a software form in bare metal. We used to call it a server. Okay, some server, it will be, these softwares will be running and then process the data. Okay, so this sometime some other occasion I will explain each and everything. Okay, or what each. So due to short of time, so we'll straightly move ahead with the use case and applications, right? So 5G use cases, as I mentioned, three magic triangle. You can see that enhanced mobile broadband, URLLC, and MMTC, right? Massive machine type communication. Okay, so these are all the some of the applications I just grouped based on the speed requirement and also the latency requirement. Based on that, I just grouped it here. Okay. Next is Internet of Things. Okay, so now the buzzword is apart from 5G, we have Internet of Things, 6G, and terahertz communication. Many things are going on, right? Okay, so now as of 2020, 53 billions are connected. Okay, for example, small things, right? For example, they are keeping the pacemaker in your heart, and then they are monitoring, they are adding some chips there, they are continuously monitor that health monitoring. Okay, similarly, for example, smart grids, where in your home they will install some small chip, kind of small module. Okay, that will keep on reporting the energy consumption in periodic basis. Okay, so likewise, we have, and truck movement. For example, if you're a truck owner, you can monitor your trucks, and it's again oil, what is the condition of oil, and many more. You can observe the overall truck performance, and also the, for example, truck performance, and where it is moving, and how what is the performance of this truck. You can just manage from this by sitting in the office. Okay, and also, for example, you can see that. JCBs, and this excavators and many things are there, right? They are also monitored by the companies, that how it is performing in the field. Okay, so many things can be, now it is becoming IoT era. So everywhere you can see small devices keep on monitoring. Okay, for example, your watches, right? So many people are wristband, right? So you when you go walk, and then when you go for a walk, then it will say that, okay, you have traveled this road and this much distance you have covered, and this much calories you have burned, like that. Okay, so those are all IoT things. Okay, so basically how IoT works. Okay, there are five processes there. First, data injection. Okay, data injection means, see, data injection means, for example, any devices to collect something. For example, you in your pacemaker, it is the chip, devices, IoT devices placed to monitor, just capture the heart performance. Okay, similarly on the truck, it can be intended for many things. For example, it can be intended to monitor the speed, intended to monitor the performance of the trucks, intended to monitor the location of the truck, intended to monitor the route of the trucks, all that stuff. Okay, next is data transmission. So I have to send that data to the some other place where the things get processed. Okay, so for that I need some kind of communication, right? That is where this 5G come into picture. Okay, 5G, or we can say LTE also, and even Bluetooth communication also. Anything is possible. Okay, just these technologies are used to transfer the data of the that was captured by the device, IoT device, to the some other location. Okay, and third step is just data processing. Okay, data processing means, see, so as an truck owner, what I will do, okay, I will just as a truck owner, what I should see. So the software developer will see that, okay, we'll process the speed of the vehicle and the movement of the vehicle and everything. Based on that, they will decide, okay, this truck is highly performed, this truck is highly performed, this driver, very good driving, had a very good driving, and he used the shortest route to reach some places like that. We can just make out many things, right? So we have to process the data, right? Similarly, for example, if you are using pacemaker, it will keep on monitoring the heart, and then send, you process the data. So just for example, you can see that ECG, they will place all the sensor in your knees and all, and in your in your hand, and also the, and in the upper part of that. Then once the data, see, it is just a signal. It will pass the signal and capture it. It will just sense the signals, and then it will be processed in the ECG machine. Then you will get a graph, right? Graph kind of thing, right? So that is the processing basically. Next is visualization. Visualization means, for example, as you see the ECG report, right? That is the visualization of data. Or you can have a many graphs, okay, to show how the performance is of the heart, or performance of the truck or anything. Okay. Next is data analysis and prediction. These are all this technique is something we need to use some algorithms, optimization algorithms, AIML, and so on. Okay, optimization algorithms to predict. For example, if somebody is using the pacemaker, okay, his heart is performing like this, he can predict that, okay, he can predict and send text that your heart is well, but you have to come for a checkup, follow-up checkup, on the so and so date or so and so week. That prediction we can make. Similarly, for the truck, no, you can just based on the oil condition and other stuff, okay, you have to go for a service and so on so date. Okay, so that way of analysis and prediction can be done. This is how they basically IoT works. This is the one part of the IoT. Maybe many other perception will be there. So I just explain my views of the Next is IoT architecture will be, for example, application layer where you just, for example, intelligent transport and logical monitoring. And this is what you see in the GUI, okay, in your graphical user interface. Next is network layer. What it does is it will just for the transferring the data between the one place to the other place using internet or cable networks or network management center and so on. Okay. Next is perception layer. For example, sensor gateways, RFID tags, sensor node in your pacemaker, or for example, RFID and intelligent terminals. These are all the three layers. Mainly works for the IoT. Next is so this is about on the right. It is just just to show you physical devices, device to device communication. Sometimes what happens is two different devices. Okay, two different devices are intended for some other application, but they can coordinate and then share some data, share the network resources, or share for example, one will help other devices. That is going to come very soon. Okay, device to device communication. Very soon, your device will be a kind of router or repeater for the other device. It is going to come in future. Okay, connectivity, edge computing, and so on. Okay, edge computing means in order to make it simplified and decision making in a very fast manner, and the data storage. So this will be a big problem, okay, in future, because you will start collecting huge amount of data, and processing also is going to become problem. That's why the buzzword called data science, data analytics, and AIML. These buzzwords are coming up now in courses also, engineering, right? Because of the all the operators, all the internet service provider, they are collecting huge amount of data. Who will process it? You cannot manually sit and process it, right? That's why cloud computing and network management and so on. Okay. Next is possible use cases are, for example, industry agnostic. It will be, for example, video surveillance, okay, environmental monitoring, and best industry agnostic will be, for example, in thermal power plant. Somebody has to go there and then monitor inspect the each and every system, right? Where you can just use drones. You can just fit it there some IoT devices. Drones can go fly around there and then monitor the temperature, or some and so on, humidity or whatever parameter you intended for. Okay, so it can do that. Okay, then you have manufacturing mining. This is another good applications where you can see that there will not be any communication between the those are persons are, for example, they may be underground, 5 kilometers down the earth, okay? So they cannot hear whatever you are saying, and they will not have a coverage also. That point of time, this industrial IoT kind of things can be there. And also for mining also, you can just, fly the drone to a certain place and then predict, wherever is mining is available. That is possible, okay? They have been doing this with the, earlier and all, they used to use small kind of aircrafts to, just to scan and see wherever the mining is. Okay. Stadium and venues, where, for example, fan engagement, crowd management, and the immersive experience, many so on. Okay. Then mobility and logistics, just I mentioned. So fleet management and cargo management, cargo trucks management, and remote operation, and so on. Okay. Next, agriculture. Anyway, you might be knowing that, smart agriculture. Now, most of the people are just installing some IoT devices, and then they are controlling the motor from the, for example, in near my village also, there's somebody, just, use that drone will just fly and then see how much is the, soil, we can say that the water content in the soil, and it will automatically trigger a message to the owner that, okay, you have to switch on the motor. He will switch on the motor from the app, just switch on. After some time, the drone again fly and then say, okay, everything is covered, just switch off. He will switch off. That's how they are going, okay? Even now it's happening. And horizontal technology, for example, augmented reality, virtual reality, and drone applications, and so on. Okay. Next is, this is a high level thing. For example, smart health, smart industry, smart buildings, smart transport, smart grid. Smart grid is already, they started in, I think, Europe and all, they are already implemented. In India also, especially in Tamil Nadu also, they are trying to do something on like this smart grid, okay? They will place one along the meter, the smart device will come. It will keep on reporting on the date of cutoff. Why it is important? For example, you have a tariff, okay? If your tariff, up to 500 units, you will have some tariff. Beyond 500 units, you will have a different tariff. Okay. So somebody has to come and take your, the EB bill, that consumption rate on, for example, let's say 10th of some month. Okay. But he did not turn out on that day. The next day he came. So the consumption was crossed to 501 or 502. Then he has to pay for heavily. Because of that 1 unit, he has to pay heavily, right? In order to avoid that, we can have, device. It will automatically keep on reporting on the date, whatever you mentioned. That's it. Okay. And in future also, what will happen is they will integrate with your payment system, UPI payment system. Then it will automatically deduct from your amount. For example, FASTag, right? This how, okay. Next is smart home. Okay, already people are, enjoying this smart home. Whenever I visit some of my relative house, they say that, okay, whenever I put switch in the fan, does not, they use the remote to do that. Okay. It's a funny things, but still, okay. Next is smart city and so on. Okay. So next is, so IoT is mainly used for, for example, new enhanced services. Okay. So they are just, for example, smart agriculture, smart grid, and smart home. Okay. Then you have a cost reduction. So because, for example, if you want to monitor, monitor something, for example, in industrial IoT, especially if a person go and monitor something, then he has to be paid heavily, and then it's dangerous to them also. So cost reduction is obvious thing. Proactive maintenance, for example, trucks monitoring, I was telling you, right? So when it monitors the entire truck performance, then you have to you can proactively do the required things, and then can monitor thing. Next is minimum user interactions. Okay, minimum user interactions, because somebody has to go and file, if anybody want to go there and then make a report and report to you, it will take some time to do that, right? So utilization improvement and so on. Okay. Next is further applications, like for example artificial intelligence. Okay. So basically network maintenance and other things, network planning. So now see, now the networks, I'm talking about this. The now networks, it is more of kind of intelligent networks, but I would say. So for example, if user is there in one cell site, okay, so that cell site is already heavily loaded with the many other users, okay. What it does is, it will offload that user to the nearby cell site where there is no much capacity utilized. That's called as traffic steering. Okay, traffic steering, many intelligent operation is happening in the network now. So self-optimized networks on RIC, RAN intelligent controller, many new technologies coming up to monitor the network performance. Now, previous days, no, olden days, for example, 2G, 3G era, somebody has to go and do the drive test, which means, they will keep some mobile and then, do just, revolve around the tower and then monitor where is the coverage is and all that stuff. Okay. Now, no need to go to the cell site itself. You can just sit here and run software and it will run, it give you KPIs. We call it as, the network throughput data, where is the what coverage level it has and where is which region it is covering, where it has an interference, everything it will give you a report. Now it is happening is you need not monitor that. Network itself monitor and do the corrective action automatically. Okay, that's happening now. Mobile broadband, for example, augmented reality, virtual reality, holographic image. Now it is very famous, right? So, so somebody will be attending in person in one place, another place, his holographic image will be there. Just kind of virtual reality kind of thing. Okay. Next is super IoT and smart home and so on is there. Okay. Next is multi-tier architecture, which means see. So see the existing core network. No, now it is existing network, right? It is so much flexible. So to have, for example, front hall, back hall, we used to call it as front hall means it is like whatever you're just your mobile is associated with. Okay, back hall means it is like core network where your user get authenticated and also many accounting and many switching mechanisms. All that happens in the so here is the multi-tier architecture. See, you can see here macro, micro, all are coming together. For example, internet and for example, end user equipment is can be railway or anything. So small cells. So all are coming up and then to cater for these kind of applications. Next is next is important communication is drone based communication. Now you might have heard 2 days ago some news from the I think in government is introducing the PLS schemes for the Indian government is introducing the PLS schemes for the drone manufacturing in India. So drone is getting now application is getting day by day it is getting increased. Okay, for example, you might have heard that Amazon is delivering the parcels through drones. Okay, I see the moment you order the trigger will go to the warehouse. It will automatically just robot will just make the pack the parcel, pack the whatever you ordered for ordered. Then it will just go and place in the drone will pick that and then deliver to the certain address. So everything is QR code based. Okay, so it will scan or it is just auto trigger mode. Okay, so the drone will have some kind of intelligence to that. Okay, this order has to be delivered. The system will choose which drone to be used for delivery and all. And another important application is that, okay, so drone can be used whenever there is an emergency situation, whereas some flood has happened and earthquake has happened, where the complete network has got dissolved. What you can do is you can, now they are talking about the network on the drone basically. Okay, what they will do, they will place the network components in the drone itself, and then it will fly to that particular region and start giving coverage to that particular area. You might have heard this in the Ukraine war, right? They used Starlink, okay, space-based things to cover the Ukraine area because there was no coverage at all. So that's how it works. Okay. Next, yeah. Just now I was telling you, right? You can use do drone to cover underprivileged area or airships or satellites, UAVs, and so on. Okay, you have many things to utilize for the providing coverage to the underprivileged areas basically. Okay, remote villages or and so on. This is the mining applications. Here you can see here that you can have a coverage to this vehicle is being monitored wherever it is going and all that stuff. Okay, and you can see that this is the cloud internet the cloud they continuously monitoring the performance of this. Next is that okay, so next is that see when you start deploying so many sensors, for example, in Spain, they just started putting sensors in the complete city, entire city was covered in the sensors. So what they did is, in order to collect the waste collection service, okay, this is auto triggered, and then to coordinate the waste collection service, okay, they monitor the trash boxes, and then collect and then send the real data to the corporation, that okay, this particular area has very little trashes, and very little, so that likewise they can manage, plan for the which area they can go. And also, if you have a sensors, you can coordinate for the this also, for example, traffic management also, right? Because in Chennai you might have feel, right, in many metro cities, okay, you can feel that they start collecting the trashes, and then just they will be, for example, during the peak time only there's lorries will go, that time a huge traffic will be there, right? So they will collect on the roads and other stuff. So this way we can also manage the traffic as well. Okay. Next is, yeah, smart city, we can say. Okay, smart city is like, for example, city mobility. You can just manage the traffic. For example, I think in some city, Poland or somewhere, okay, you can just install the app where you can just go and request for some service. For example, you want to visit some places, it will show you all the options. Okay, that which bus you can board, and which is nearby, and all that stuff it will show you. Okay, advanced mobility management. Next is environmental. See, many agency, right? For example, hospital, transport agency, utility agency, police, and environmental agency. So everybody will be getting huge amount of data to process. Okay, public safety and other stuff, right? So it's like a kind of surveillance. All are integrated together in the IoT platform, where what you will do is, you will process all those data, and then for example, hospital related means, for example, you can monitor the ambulances. Okay, for example, some places, some accident has happened, ambulance is coming, so you can just prepare, okay, this ambulance can be diverted to nearby hospital, right? That way we can just guide that hospital to the nearby hospital, then it will be auto triggered and then send information to the hospital itself, that they can prepare the bed and ready, okay, to save the lives. Okay, similarly for fire station, somewhere some fire has happened, sensor will just capture that fire, and then means capture the that fire is happened, it will auto trigger the message to the fire station, the fire station start go and do that. Okay, all these are sensor nodes will be there. So with this way we can manage all these items basically. Next is, see, this is what I was telling you, right? We collecting of data, and then visualize, analyze, and guidance. Okay, so this will be the kind of this is where for example, collection of data, right? This is where this 5G network come into place. You can see here it's a kind of interface, a collection of data as well as the actions. So planning and optimization, it will send you the actions also to the respective equipments, or IoT device, or and so on. So for sensing as well as the send back the actions, these 5G networks can be used. Okay. Next is this is about the network management systems, and also the, for example, you can integrate many technology together. For example, next is to reduce the network cost, and also the if you are having, for example, IoT device applications. Okay, yeah, one interesting application I can tell you that in Japan, so they use drones for monitoring the cell sites. Basically, the drone will be going to each cell site, inspect all the cell site, monitor each and every cards together, and then it will just ensure that network is the equipments are running fine, and the environment is good, nothing is no things are harmful, and all that stuff. So that also they are using for this thing. Next is IoT perspective. So the see, when you are having this much leverages, okay, you will also at the cost of security issues also, right? Security and privacy, and data reliability. See, you are collecting all the data, entire data. Okay, so what will happen to the data reliability, right? And many things to be maybe still I think IEEE and many standardizing bodies, they are working on that. I will shortly cover on that. Okay. Next is wireless network on drone. Just before I was telling you, right, wireless network on the drone. This will be triggered during the emergency time. Okay. So what will happen is, drone will just go and, connect to the nearby network, wherever his network is active, cell tower is active, that's, use as a repeater kind of thing. It will act as a repeater to provide coverage to the underprivileged or, disaster area, basically. Okay. Next. Yeah, this was, I was telling, like standards, right? So usually standards means what? It's just a set of procedure where, several technocrats come and sit and then, decide that, okay, when you are introducing some technology or applications or anything, right, we should think in many perspective, right? So implementation perspective, and what will happen to the society, and what will be the implication, whether it is the application is really required or not, whether this technology is really required or not. Those things will be discussed by the standards. And once the technology is confirmed that, for the using, okay, then they will decide that, okay, they will, provide some set of procedures that, okay, so this standard, okay, if your device has to be sold in this particular area, this particular applications or this particular country, you have to comply with these standards. Okay, what standards will say? They will tell you. For example, you can see here. So if you want to know about the internet things, IoT architecture, reference architecture, you can refer this and then get to know. For interoperability things, you can just go to this. Okay, each spec will talk about its own, given task. Okay. So for example, you can see here defined standards and applications for the smart cities and communities. If you want to know about the IoT applications in the smart cities communities, you can go on very well go and refer in the ITU books. Okay, I mean, so some of the standard documents. Okay. So similarly for the one M2M, you can see, I think it's in India, I think they developed. Okay. So the some of the releases are going on, and the IEEE also they are doing some kind of standards in the architecture framework for the Internet of Things. So here you can see that this is how the standard works: ITU, 3GPP, and so sometime what will happen is some standard body will go alone, or some standard body. Sometime what will happen is they mingle with others, and then they collaborate with others, and then come up with some good standards, basically. Okay, you can see here ITUs or ITU, IAC, those standards are providing for example secure element. Some of the aspects they cover keys and certificates and so on. Some one M2M is just national trust. Some part of the work they will do. Okay, some part of the things they will ensure. Next is bootstrapping and see 3GPP and so some part of the IoT networks, right? They will take care of this. Defining the somewhat of the IoT networks, they will take care of this. It will be taken care by the 3GPP. Similarly for other standard as well. Okay. Next is just for example, you can see here that each application. See, if you want to sell your device for the smart city application, you have to comply with these standards. Not only this, there will be plenty of standards you have to comply with. Plenty of testing will be undergo. Your device will undergo, and so on. Okay. Similarly for the other applications. Okay. Next is summary of a standard related. See, standard related is like, for example, if you want to, have some IoT networks, right? You need some kind of framework. Okay. For example, if you are building some applications or software or apps, you will start building the framework, right? So, okay, this will be my input. This is how the architecture will be. Where this input will go here, and then this output of this will go to here, like that. You will just know. And this is how high level reference architecture you will just build. Then you will start seeing that how will it be, it will be coordinating with the other networks, or how it will be devices, what all devices can be used, how the device should be looking like. So many aspects are there. So everything will be defined by this, most of them will be defined by this standards related. And policy and regulation related, which means, see, for example, network address, right? Everything is IP based, right? So you cannot have you do not have leverage to have so many IPs as like you want. Okay, so spectrum requirement and all that stuff. So need to be, for example, regulatory body will come into picture. In India, I think TRAI is there, right? So they will regulate the frequency usage and all that stuff, right? Similarly, each body will have their own each aspects will have their own stakeholders, access to data, open data. These are all policy-driven things. Okay, so some country will deny the, so no, you should not access the customer data. Some country will say, okay, you can do whatever you want. Okay, just to use it. That's it, right? So similarly, each country will have their own policies, okay, and quality of service and other stuff. Next is, madam, how much time I have, madam?
Sir?
How much time I have, madam? 20 minutes?
12:50?
Okay, so I will try to cover. I think I will close by 12:55. 12:55.
Try to cover all 52 slides, sir, as a glance. We are very much interested. You have
Just 10,
52 slides, yeah.
10 minutes, madam. I will just
Yeah.
Okay, madam. So now we'll just see any device for that matter. Okay, it can be a radio unit, it can be IoT device, it can be a mobile or anything. Okay, so the design cycle will be like this. Okay, you will conceive the concept. Okay. When they might have started with the IoT device, right? Okay, they might have said, okay, what for this is. See, main thing is requirements. Okay, so when there is a requirement, you will start thinking of, okay, whenever you are seeing some applications, for example, see, well, a cycle, right? They might have think that, okay, we cannot walk a certain beyond certain distance, right? They sort of, okay, we have to go faster as also, and also the, we have to reach without, without having spent much energy, right? They started inventing cycles, right? In cycle also, so many variants have come up, right? So that's how, initially you have to specifications. Okay, what is my application target? What I am going to do? So that concept, conceiving the concept or assimilating the concept is first thing. Next is this hardware design and development, which means it will start with the high level design. Okay, yeah, mobile means, okay, it will have a camera, it will have a display, it will have antennas, it will have power buttons, it will have battery, it will have for example, these things are the high level design development. Okay, then they will go for the low level design, which means each model, battery means what sort of battery, so battery management system should be there. So what sort of power system I have to use, what sort of antenna I have to use, this will be the low level design in the module by module. Okay, then component engineering, which means, so which component I have to use, because I have a space limitation, regulation limitation, all the sort of limitation, right? Those things. Okay. Next is PCB design, fabrication, assembly. Okay. PCB design means, so you will just, you come up with when you come up with the low level design with all aspects. Okay. You will just, design each module separately. Finally, you come up, you put that in the layout. Okay. Initially, just like you do it in the breadboard, right? Initially, you validate some things in the breadboard using breadboard. Then what you will do, once it is success, okay, it is working fine as expected, then you will go for the PCB design. Same thing here also. You will just start experimenting with the high level components and other stuff. Then you will go for the PCB design. Then you have the, for example, mechanical design and enclosure, which means mechanical means, see, mobile have, for example, it has the, we can see that, uh, uh, we can see that, say enclosure is there, right? Any device can just a PCB, you cannot put that in the any place that you want. Okay, so therefore that's why we can see that mechanical enclosure is very important. Next is firmware and apps and cloud. Okay, firmware means, see, any board will have some kind of controller, right? For example, in your motherboard, you used to call it as motherboard in your PC, right? So for that, you need to develop firmware. Okay, so how each component is working, how you have to create some kind of software packages to make it integrate all the functions and to enable some module to work the intended one. Okay, for example, on OS is, for example, Linux, RT Linux, and many OS are there in the devices. Next is the NPI, which means, see, product certification. For example, once you are done with the everything, okay, you are done with the software and everything, you are integrated, your system is working fine, then you go for the compliance testing, okay, or testing, various kind of testing. Once all are completed, your prototype is completely ready. Okay, then what you will do, you go for the manufacturing, basically. Okay, manufacturing, then production testing, we used to call it as. Okay, so any device, for example, in just a simple mobile device or device, you will have for example, you can see that higher layers you will get the bits, then you will process that in the RRC. RRC will be for control. PDCP will be for the data segmentation. So higher layers you will get the chunk of data, many huge amount of data. You will make that as PDP packets. Then you will do all this stuff. For example, LDPC coding, scrambling, modulation. This is just high level. Each device will have a different things. Okay, different upon the technology that you use. For example, beamforming and other stuff. Okay. So then, for example, this is about the overall architecture. Next, I just, as we are from the RF background, so RF front end will have, for example, you will have IQ samples coming out of the DAC. Then you will have filters to suppress the, the noise that out of the band. Then you will have mixers to convert that into the another frequency. We call it as, digital. See, there is a two kind of conversion. One is digital based, up conversion, down conversion. Similarly, for the analog also, you have up conversion, down conversion. So then you will have, for example, band pass filter. Then you give it to the PA, power amplifier. Then you will give to the duplexer. This will be transmitted to the channel or free space, we can say. Then you are receiving from the free space. The same thing will happen, just exactly opposite. Okay. This is how any general RF oriented architecture will be. Okay. So this is how any radio will look like. Okay. So this will hold good for even IoT device also. Okay. Any IoT device will have, for example, if it is working in that RF band, then you will have a RF front end and baseband section and everything. Okay. Next is just to highlight about the antenna evolution. Initially, we were just 90s kids were talking in this fashion. We used smart antennas that time, but now kids are like this. Okay, just unfortunate. Okay. Next is just it's not required for you. Okay, just how these antennas are evolved, and and MIMO. Okay, several MIMO techniques came up for the time diversity, frequency diversity, space diversity, and MIMO modes. It is for the spatial diversity, means you will send the same data in the both the antennas. Okay, you collect it, and which one is best, you will just take it that. Okay. Next is spatial multiplexing, which means you will use send one data through one antenna, another data through another antenna. It is for the capacity addition. Okay, you will aggregate both of them, combine both of them in the receiver, and then use it. Okay. Next is MIMO types. So single input, single output. So it was the case till 2G era. Then they came up with the MIMO. For example, we had several multipath signals. In order to make use of these multipath signals, they came up with this MIMO technology, single input, multiple output, which means your receiver will have a two antennas to receive. With the two copies, whichever is best, it will take it. Okay. Then TX diversity, you will have a transmitter. You have two antennas to receive, and then the receiver will have one antenna, but receive both the copies and then decide which one is best. Next, we will have multiple input, input, multiple single output. Similarly, single user, multi user, MIMO, for example. Next is next level of thing is like a massive MIMO, where you will see that you will have plenty of massive MIMO means see massive massive number of antenna elements with a massive number of MIMOs. That's it. Okay, it will have both the spatial diversity as well as the spatial multiplexing and many more. Enhancing the throughput as well, like SNR as well. For example, with the help of beamforming. Then this is about the just performance metric. It's not required for you. Then advantages of MIMO, it is highly spectral efficiency is high and reject the interference, because when you have interference here, then you will your network will be collapsed. So therefore, in order to reject the interference, I can use the point beams pointing towards the user. Okay, so therefore I am just I will just send the null towards the null means zero signal towards the interferer. Okay, so many advantages are there. Then any phased array will have this kind of architecture, analog beamforming, digital beamforming, hybrid beamforming. Okay, so the how phased array work is like, for example, if you see this is the Butler matrix, simple Butler matrix. Whenever you input one, see if you are inputting here, if you are giving input to here, then you will get a one beam, then another input, just to have a feel of how the beamforming works. Next is just challenges and opportunities. For example, as an EC engineer, see, we face a lot of challenges when we, uh, you know, uh, when we start working on that, when we start working on the, any device systems. Okay. See, for example, you can design the module, each module, independently. It will work very, very much fine. When you start integrating, it will start creating a lot of problems, basically. And nowadays, you have a very compact thing, so therefore the a compact, when you are moving towards the compactness, what will happen? Complexity increases. But the problem is, see, now we are going for compactness, but at the technology features are, keep on increasing, basically. That is, a kind of a reverse way. So therefore, your complexity will increases. And for example, nowadays, we are having system on chip, system on package for some kind of RF system, and also for the array, it's coming up. And about the beams, CAD modeling, we will have a problem in the mechanical design. CAD modeling. So multi-layer design, so it will be, each one will be very precise manner. Then in antenna itself, we had a lot of space, a lot of parameters to look at when you do any design. Okay. And beamforming, you can see that algorithm. When you are if you are a signal processing engineer, you will be very good enough to design this algorithm. Okay. That's why that is where you find a lot of opportunities. So many beamforming algorithm development, and many other designs and other stuff. Okay. Then fabrication side, you will face a lot of challenges. Okay. Because selection of substrate, which substrate to use, what thickness to use, surface roughness, what type of laminates you have to use, how we place the components, and then the stuff. Okay. And EMI issues also will come up when you start integrating things together, because a lot of harmonics will come up. Then characterization, then you have simulation process. So nowadays, you cannot have a individual module simulation. You have to have an integrated simulation in order to avoid the future problems during the integration. For example, like this. So you will design the circuit, RF front end circuit here and antenna here, and then at the same time you evaluate both, and then in order to get the intended performance. So some kind of antenna performance, antenna measurement techniques, anechoic chamber, near field measurements, then 5G conductor testing. This is the radio, basically. This is how they test the radios. 5G OTA testing. So this is why, especially for the testing the beamforming and also other features. Okay. Then you have testing tools. So for example, especially MATLAB, please try to learn MATLAB. Okay. Because everywhere it is used. Okay. You can model any network in the MATLAB itself. That is possible. So that's why, please try to learn MATLAB if you want to get into any opportunity. You can be a signal processing, you can be an antenna engineer, you can be a signal circuit engineer, PCB engineer, anything. It's fine. At least, you can just, with the MATLAB, you can just have a feel of, okay, how the system works. Okay. Then PCB layout has a lot of softwares, and similarly for the other softwares. I think I am on time. Okay. Okay. So to conclude, we started with the preliminaries. Okay. So how things are in the 5G, and then we just mentioned about a few enablers of 5G, and also the few key points about the 5G. Then we had IoT use cases. Okay. Many use cases, applications we have is considered. Then system architecture, and also the various MIMO scenarios, some of the challenges involved in the RF front end, and any radio unit or IoT device for that matter, and simulation measurements.